Yeah, probably not. Kaboom! That is a camera shot. Last week we took a trip down Struggle Street with my 1963 Studebaker Lark. And today we're going to talk about how to make launching a manually shifted car a breeze. With a manually shifted car, it can take a bunch of driver skill. And my goal for this video is to show you that we can take most of the human error out of the process and make it so that anybody can do it. So let's start off with the basics. With a manually shifted car, what you're going to want to do before you launch is, of course, push in the clutch. Then what you're going to want to do is start to build up a little bit of RPM. Now, to make this part of the process easier, what I highly recommend is the installation of a two-step rev limiter. What this will do is it will automatically hold the engine RPM at a certain RPM that you can adjust when the clutch pedal is depressed. Then when you let the clutch pedal out, it will allow the engine to rev higher. And basically the goal with the two-step is to make launching at a particular RPM as consistent as possible. We want to make this process way less of an art and way more of a science, so our goal here today is to make things as consistent as possible. Now, once you've built up some RPM in the engine, you're going to have a lot of rotating inertia from both the weight of the crankshaft and the weight of the flywheel. And this inertia can both be a huge advantage and a huge disadvantage depending on how it is applied. The goal is to use this inertia to its maximum potential and get the car to leave the line as quickly as possible. The problem is if you apply it too hard, like we found out at the drag strip last week, you're gonna break stuff. So there's a couple different philosophies with this. Some guys just dump the clutch. And when you're running a bias ply slick on the back of your car, this can work okay. And the goal is to sort of slip the bias ply slick so that not all of that energy is put as a shock load into the drivetrain. But you're almost always going to bog the engine when you do this. And for the guys that make a lot of torque, you can sort of get the engine to grunt out of that hole and you don't really lose a lot of ET. But there really is a better solution to the problem, and that is to slip the clutch. Now, like I said, for guys running smaller engines, this is almost a necessity because you just don't have the torque that some of the larger engines do. And if you fall down into that hole, you're gonna take a long time to get out. And there's also advantages to the guys that do make torque. If you can keep the engine more in its power band and just slip the clutch and apply it more gradually, the car will usually ET quicker than if you were to just let the clutch fly and try to slip the tire. In my case, I am running a drag radial tire, so slipping the tire is not an option for me. Now, it is possible to slip the clutch manually using your foot. And what you're going to want to do there is you're going to want to push in the clutch, put it on the two-step, and then you're going to want to let the clutch out to where the clutch starts to grab and sort of hold it there. And you're going to slip the clutch until it feels about right, and then you're going to let it the rest of the way out. This takes a lot of driver skill and a lot of trial and error. And I don't really want to learn it because you're going to have a trail of broken parts. And frankly, I just want it to work, and I want to go have fun and row gears in my stick shift Studebaker. So there's got to be a better solution. Today we're going to go over the installation of a Hitmaster two-stage clutch hit control system. Alright guys, one of the things I really like about this system is the detailed written instructions that they provide with the system. I am definitely a guy that appreciates a good manual. Maybe I'm weird, I actually like to read the instructions. Better to learn from somebody who's done it a million times than to try and learn it yourself. Alright, so what the kit includes is this piece here and this piece here. This you should already have on your car. That's your slave cylinder, and I opted to not get this with my kit just because I wanted to do the timer through my ECU for ease of adjustment. Alright guys, you probably guessed I was going to break out the whiteboard to give you guys an overview of how the system works. So let's get into it. This is basically what the system consists of. Here we have your clutch pedal, master cylinder, and that plumbs down into your slave cylinder down here. And then we have this, what I'm calling the accumulator, and of course the little line lock solenoid. So basically how this system works is when you press down your clutch pedal, you will make pressure in the system. In my case, it's about 350 psi, and that will flow into all of the orifices. So everywhere that you see here is now 350 psi, and our slave cylinder will move out and depress the clutch. Then, to arm the system, you need to activate your solenoid, which will effectively open this circuit right here and basically close it off from the master cylinder. But since there is still 350 psi everywhere in the system, nothing is going to change. Then, when you let off of the clutch pedal, this pressure will now go down to 0 psi. Same with this pressure right here, 0 psi. And now that we have a pressure differential across our accumulator, the piston will move this way, and it will move until it gets the whole way over to here. And basically it lets off a fixed volume from our slave cylinder. So our slave cylinder will let force off of the clutch, but not all of it. And this will reduce to some lower pressure, let's call it 200 psi. Then when we are ready to fully release the clutch based on that timing function, this solenoid will get closed again, and that will let the pressure that is in this lower circuit back up to the master cylinder, and that will let this part of the system go to 0 psi, 0 psi, and our piston here will return to its home position, and it will let the slave cylinder the rest of the way out and fully release the clutch. So if we were to look at this on like a graph of the clutch position versus time, we should see a behavior very similar to this. So when we let the clutch pedal go, it should go down to some fixed position, and then when we release power from the solenoid, it will let the clutch the rest of the way out. Now the nice thing is with that accumulator, it is adjustable, so we can change this point here to be higher or lower depending on our needs, and we can slip the clutch more or less. Also, we have the option to sort of PWM the solenoid as it releases on this side of the equation, so we can bring it out more gradually when we're ready to let it go. So next I want to use this graph to give you a reason why I went with this system. Since the system is all mechanical and it always lets the same amount of fluid out of the slave cylinder, we know that it is always going to go to the same point or the same initial hit. Now, a lot of you probably are thinking, why didn't you go with the Bangshift Billy? The Bangshift Billy is actually a pretty similar concept to what we have here with the Clutch Tamer, except you eliminate everything over here. The Bangshift Billy consists of two timers. There is one timer that you set up to time from when you start to let the clutch go to when it cuts the fluid path off. And then there is another timer for when it lets that fluid flow open back up and release the clutch the rest of the way out. The problem is it is all time based. So based on what you put in the app, it is always going to close the solenoid and open it up again at the same exact time. The problem with this is if I let the clutch out slowly one time, it's going to be at a totally different clutch position than if I let the clutch out fast the next time. So you can have a lot of human error and your clutch position could vary pretty wildly. With the Clutch Tamer, it always lets the same volume of fluid out, so it's always going to go to the same clutch position based on where your accumulator setting is. Now, if I were to go with another popular solution, something called a flow control valve or a slipper valve, you have the problem of it's really hard to stage and cut a light with that. And basically how a flow control valve works is it will just let the clutch out at a given rate, which you can adjust with a knob. So you can make it longer, you can make it shorter, but you can't really make it hold the position or do anything fancy like that. The problem with this is, let's say your clutch grabs right here. There's all this dead time from here to here when you let the clutch out to when the clutch actually grabs, and that can make cutting a reaction time really hard. Because of this, what guys who are running slipper valves will do is they will actually let the clutch out to where it's starting to grab, and then when they launch the car, it will let the thing go at the given rate. This can have all sorts of inconsistency because you may have it higher up here, have a little less grab, or lower down here, have a little more grab. And it almost requires that you put a handbrake into the car so that you can stage it properly. Also, you might have issues with rolling through the beams on accident. Therefore, I think that the Clutch Tamer is the ideal solution for the problem. But let's show you guys how it works on the car. So the system, as I have it installed on my car, I have the solenoid hiding down here on the frame rail, and then I have it plumbed as the instructions describe. And then I have my fluid accumulator here, which is accessible by me from the driver's seat, and I can make quick adjustments. Now, there are hundreds of ways that you can wire this system. In the instructions, they recommend you put it on your line lock solenoid, and then when you launch the car, you let go of the line lock, which will activate the timer and hold the Clutch Tamer for a given amount of time. But I did it a little bit differently. I have this CAN keypad here, and I have it configured so that this first switch here is to activate the Clutch Tamer, and then this second switch here is sort of a manual override, so that if I want to just test the system, I can literally just turn the solenoid on and off. So if we watch my clutch pressure, which is just a pressure sensor which is plumbed into my clutch line, when I press down the clutch, we will make some clutch pressure. Then I'm going to just manually activate the solenoid. If you heard that click, that was the system activating. Now I'm going to let off the clutch, and you can see that it holds pressure onto the system until I deactivate the switch. So in actual practice, what will happen is I will do my burnout without the Clutch Tamer active, and then I will hit this switch, which will also turn on my two-step rev limiter as sort of a reminder to turn the system on. Then I can hit my clutch pedal, floor it, you'll hear the solenoid activate, and then as soon as I let the clutch pedal fly, it will go through a timed release of the Clutch Tamer. And just for fun, we can watch the clutch pressure, and you can see that the system works. Alright guys, to show you how this thing works, I'm going to take my bore scope and I'm going to fish it up into the bell housing of the engine. I'm going to look at how the clutch slave cylinder reacts when I make changes on the clutch tamer. So let's check it out. One of the things I love about the Clutch Tamer system is it takes all of the human error out of the system. Well, I guess you could still forget to turn the thing on. And taking that human error out of the system makes it way easier for you to make changes because you're not guessing on what it did, what it didn't do, and you can make changes that will do predictable results, and it just makes the system a whole lot more scientific. So, let's take the thing out in the driveway and see how it works. Alright guys, I hope that you enjoyed today's video. I think that our test in the driveway is showing some really encouraging results, and I look forward to actually running this thing down the track. Unfortunately, that's going to have to wait until a future video. So with that, we're going to wrap this video up. Make sure you like and subscribe, leave a comment. See you in the next one.